we are going to review how to solve this distance, rate, and time problem. Keep in mind, these word problems take a lot of setting up, so be patient with yourself when you're trying to solve these problems. Don't try to rush through these, because these are probably one of the hardest topics you will work on in this course. For this topic, what I recommend is to draw a sketch to represent the situation, because it definitely helps to have a visual of what's going on in the problem. So here it says in the first sentence, 2 buses leave a station at the same time and travel in opposite directions. So I'm just going to put a little point here, and that's going to represent my starting point. And let's say that one bus is going this way, and we have another bus going this way. So for the next sentence, it says one bus travels 9 miles per hour slower than the other. Okay, so I'm not going to really draw much with that yet. If the 2 buses are 345 miles apart after 3 hours, okay, so let's say that one bus, so we have our starting point. Let's just say that the bus that's in red, represented by red, let's say it gets this far. And remember, in the second sentence, they said one of them is 9 miles per hour slower. So what I like to do is draw one of the lengths that's shorter than the other, because if one is going slower, that means if they travel the same amount of time, that it's going to travel less distance. So here you can see that the one in red is going slower, the one in blue is going faster, because the blue covered more distance. So now I'm going to go back to that second sentence, and I'm going to add that to my notes. It said one bus travels 9 miles slower than the other. So this is an important note here to keep in mind, is that if they tell you that one of them is slower than the other by a certain amount, that means the 2 rates are related to each other. So their speed is related to each other, which means we can use the same variable to represent speed. So I'm going to make a little side note that x is going to be the speed, or in other words, the rate, right? How fast you're going. Now, the rate, so I'm going to label it as the rate for this one is going to be, let's call it x, right? And it's a slower one, keep that in mind. The blue one's rate, I'm going to say, remember, since one of them is 9 miles slower than the other, 9 miles per hour slower, that means that this one, like if I leave it like this right now, they both have a rate of x, which means they're the same speed. But if I want one to be slower than the other, then what I have to do is, to show that it's 9 miles per hour slower, is take away 9 from 1. So I'm going to take away 9 from this one, because we're saying that the red one, remember, we said that it's slower. And this is like I said, this is the most important part here to understand, is that if I leave it this way, r equals x for both, we're saying that the rate is the same for both. But since they told us one is 9 miles per hour slower than the other, then I'm going to put minus 9 for this one, and that means that my rate is 9 miles per hour slower than the blue one now. So red is 9 miles per hour slower than the blue. If the 2 buses are 345 miles apart after 3 hours, so let me add in here that that's saying that the distance from here to the other side, so that whole distance here is 345 miles apart. Okay, so that's how, if you look at where they ended up, that's how far apart they are. And this was after 3 hours. So they traveled, so that's a time they're giving you. So the time is going to be 3 hours. Right, that's how long they traveled for. So I did my 345 miles, I put how much time they traveled for, and they want us to find what is the rate of each bus. So if you notice, I put x equals the speed or the rate here. So that's going to be my unknown. We're going to try to find x. What is the unknown in this case? We don't know it yet, but we are going to find that rate. And just to add a little bit more notes, in the red, I'm going to put a little s down here to represent slower, and for the blue one, I'm going to put an f here to represent, that's my faster one. So this is when I read it, is the rate of the slower one is equal to x minus 9. The rate of the faster one is equal to x. Notice that we have a distance, so this 345 is a distance. This rate, the r, these are rates, and they also gave us a time here. So we have 3 different variables, distance, rate, and time. There's a formula that relates all 3 of them, and the formula is d equals r times t. So distance is equal to rate times time. Now that we have a better understanding of this problem, I'm just going to add a couple more things that you're going to need. So looking at the bus that in red, we noticed that it traveled this certain amount, like a small amount. So what I'm going to do is I'm going to put down d for this one. This is the distance of the slower one. We don't know it, So I'm just going to leave it like that for now. So that's the distance of the slower one. Then this one in blue is the distance of the faster one. Again, I don't know how much distance it covered, but I do want to represent that variable there. Because remember, we're using the formula distance equals rate times time. So I want to just have all that information together. I'm also going to add the time travel for the red. So the time of the slower one is 3 hours. And the time of the faster one is equal to 3 hours as well. So even though I had the note over here on the side, I'm putting it here just so it's all grouped together, so I have a better understanding of the problem. There's a relationship between what we have in front of us. And let me just give you a little side note here as to what I'm going to use. I'm going to apply this idea. So let's say I gave you this segment here that's, let's say it has length 10. And I told you that the length from here to here is 3. And then I asked you to tell me, okay, what's the length from here to here? Well, if I told you this whole thing from here all the way to this side is 10, and we know that from here to here is 3, then I also know that it has to be true that this has to be 7. And how do I know that? Well, because the sum of the smaller lengths, so if I add up the lengths of the two smaller parts, it should equal this entire thing. And we're going to use this idea for this problem. In other words, so now notice that we didn't have, in this problem we didn't know the distances, but I do know that the distance of the slower one plus the distance of the faster one is equal to 345, right? Because the whole thing is 345, and we know the distance of the slower one is represented by d sub s, and the distance of the faster one is represented by d sub f, right? So ds plus df. And now the cool thing about this is that now we're going to use that formula, the distance equals rate times time. We're going to use this part. So d of s, let me represent it in the formula so you can see. So we know the distance of the slower one is equal to rate times time. And then the distance of the faster one is also equal to rate times time. And don't forget that we need the rate of the faster one here and the time of the faster one. And this is the rate of the slower one and the time of the slower one. So let me substitute into this formula what we do know. We don't know the distance of the slower one. We do know the rate of the slower one is represented by x minus 9. And since I have two things, I'll put it in parentheses. And that's going to be multiplied with the time of the slower one, which is 3 hours. And if I want to simplify it, I can. I can distribute the 3 in here, and I'll get 3x minus 27. So this is the distance of the slower one. It's represented by 3x minus 27. The distance of the faster one we don't know. We do know the rate of the faster one is represented by x, and the time of the faster one is also 3 hours. And if I simplify this one, it would just be x times 3 is the same as saying 3x. So now I have my two distances of the slower and the faster one, and I can go ahead and substitute this information into my equation that I wrote earlier. So d of s, which is the distance of the slower one, I could replace it with 3x minus 27 plus the distance of the faster one, which is 3x. Bring down my 345, and you can see now we are ready to solve the problem. We have an equation with one unknown, which is the x. All we have to do now is just simplify it and solve for x. So if I combine like terms, I would get 3x plus 3x, which is 6x. Bring down the minus 27 equals 345. Let me just bring this down a little. Add 27 to both sides. And we get 6x equals, and we get 345 plus 27, which is 372. And then in my last step, I would divide both sides by 6. And I would get x equals 372 divided by 6, which is 62. And now I have the value of x. And don't forget in my notes, if you look up here, x is the speed or the rate. And remember, if you look at the question, let's zoom out a little. The question was, what is the rate of each bus? So we need the rate of each one. So let me go back to my notes, which I said I had the rate of the slower one, which is represented by x minus 9. And we also have the rate of the faster one, which is represented by x. My last step now is just to substitute my value for x. So x was 62, replace it here, and when I simplify, I get 53. Doing the same thing for the rate of the faster one, I replace x with the value I found, which is 62, and then that one's all set. So we have the rate of the faster bus is 62, and don't forget it was in miles per hour. And then the rate of the slower bus was 53 miles per hour. And you can see that the rate of the slower one is in fact 9 miles per hour slower than the rate of the faster one. So as you can see that this takes a lot of work, so be very patient with yourself and take your time when you're taking those, setting up your diagrams, because that is the most time consuming part of this problem.